Okay, welcome back everybody. Today it is factoring by grouping. That's what we're calling this section. Okay, it's lesson 1. It just says factoring polynomials. But you factored before. It's just you're going to be learning to factor by grouping. All right, this one's actually a pretty rough way to start on a Monday after a 2-week break. That's where you're at. So let's just go back to, let's say we had x squared plus 3x plus 2 equals 0. Or equals f of x. Everybody add a page or just find some room to write this one and just factor that one and then tell me, once you got it factored, what the solutions are. There's also known as the roots, the zeros, the things that solve this equation. All right, that is what I'm going to make sure now. Yep, I think that's what I was looking for. Yes. Turn it my way and I'll tell you if you're doing it right. Yep, that's what I was looking for. Those are the answers. Yes, yes, yes. Go ahead and find the solutions if you haven't already. Good, 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 good. Can you zoom in a little tighter? It's hard to read that. Yes, 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 yes. Okay, good. So the process here was factor it, and you get x plus 2 and x plus 1, and then this part equals 0 and that part equals 0. X plus 2 equals 0, x plus 1 equals 0, x equals negative 1, x equals negative 2. So there's 2 quick answers. Those are real solutions, right? How would you have known if they were imaginary? Well, if they were imaginary, it would have looked something like this. It would have factored to like x squared plus 1 and x minus 3. And this part, again, this is a totally different question, okay? But let's say I get one factored down to this. This one has one real solution of x equals 3, but then there's this part. Why is that going to be imaginary? Because there's no way to make this equal 0. Because you'd have to have x squared equaling negative 1. And that's not possible, right? So everybody please write x squared plus 1 equals 0 and then solve it. Hopefully you remember how to solve things that have negatives underneath square roots. Square root, and this square root of an x squared is absolute value of x. That is so critical. You can't think that the square root of x squared is x. Otherwise, you'll forget a couple solutions. You might have even remembered, if you forgot the absolute value, that the square root of negative 1 is I. I hope you remembered that. And then hopefully you remembered the final answer has to be 2 things because of the absolute value here. You split it into x equals I and x equals negative I. So it's plus and minus I is your final answer. If you want to put them back together and say plus and minus I, that's good. Raise your hand if you had that right. Okay, that's only half the class. I'm going to try one more. X squared plus 2 equals 0. Just solve that one. It's very similar, but it will be different. So that's as if the problem had been x squared plus 2 and like x minus 5. And it got all factored to that. We'd set this part equal to 0. All right, so subtract 2 from both sides. X squared equals negative 2. Now I square root, and absolute value of x, I hope you remembered. And this one, it doesn't just break down to 2i. It's the square root of 2 and the square root of negative 1. That's technically what you're doing. And then this part doesn't work out nice, so you have to leave it there. This part works out nice. It's I. So you'd have absolute value of x equals I root 2. And then am I done? Nope. One more thing, which is what? Plus and minus. So x equals plus and minus I root 2. That's how you find imaginary solutions. Hopefully your brain's slowly warming up here. So if I asked you this problem that we just did is kind of like this. If I were to take all of this, move it all down, What would the problem have been before this? Well, if I FOIL this thing out, it'll tell me what the problem would originally have been. Firsts, x to the third. You know what I'm saying? Would you please multiply this thing out and tell me, FOIL it out, tell me what the original problem would have been in the first place. So all I'm asking you to do is FOIL that thing out. First, outside, inside, last. The outsides would be that and that, minus 5x squared. The insides will be this, 2x. And the lasts would be x, or the 2, sorry, that would be the last, and that makes minus 10. And they might say f of equals f of x. Why would f of x be 0 again? Because we are trying to find the zeros, the x-intercepts. The x-intercepts are where y is 0, right? So this is like y, right? So we're setting that equal to 0 so we can find the x-intercepts. That's why we'd have set that equal to 0. So there's your original problem. You're going to be learning to factor things like this today. What did it factor into? This. It's kind of messy now because I had all that other stuff with it, but there we go. This red line right here, that's what it factors to. Okay, so how on earth do you factor something with 4 parts? We'll get there. I want to kind of show you one thing at a time. I did tell you before break, I pre-taught this, and some of you may remember it. Some of you may have caught it. So now I feel like you're ready to try factoring something this hard. So hopefully you can just set up 2 sets of parentheses and factor it. This does not need any magic. It just needs you to figure out what has to go here and here first. And that's the 2 things that will give you the firsts. That. By now you should probably have it. What did you have in both spots? Say it. X squared. Good. Because x squared times x squared makes x to the 4th. And then these 2 numbers, the one that goes here and here, they multiply to 8. Don't get all confused by the middle term and stuff. Just make sure you know, okay, I got to get 8. So it's either got to be a 1 and an 8 or a 2 and a 4. My gut says it's a 2 and a 4 because I know that the middle term is a 2. And a 1 and an 8 don't make a 2 very nicely. But with a 2 and a 4, I'm sure I can make a 2 come out in the middle. All right. Now, do I know for sure that the 2 and the 4 are in those spots? Nope. I'm going to just keep playing with it until I've FOILed it out and it actually gives me my original problem. So could this be it? Well, I need pluses and minuses. One of them has to be positive, one has to be negative. I hope you put the plus here and the minus here. Let's double check. First, x to the 4th. Outside, 4x squared. Inside, minus 2x squared makes 2x squared. And then the last, negative 8. Yay, I've got it. The only thing I have to ask myself is if I could factor it further or not. Now, I want to stretch your brain here. If this thing is supposed to equal 0, then can this one give me real answers or imaginary answers? Which one is it going to give me? It will give me real answers because I'll have x squared is equal to 2. And then I can actually get that. It'll be plus and minus square root of 2. I skipped a step there. Square root and square root. Then this was absolute value of x. And then that reminded me there was plus and a minus, right? Okay. And then over here, will that one give me real or imaginary solutions? Imaginary. Now, there's 2 ways to do it. You can either do it with the way I was describing before as get the clump alone. So I'd subtract 4 from both sides, and then this clump right here would be alone. And then I square up both sides. But do you remember how to factor that part, even though it's imaginary? Come on, you can do this. You remember? What is it? Close. You're missing one thing, otherwise this would just be a normal one. That's what you'd do if that was a minus. Come on, what's different about it? It's going to be imaginary answers. Plus 2i minus 2i. Now, if you do it that way, you don't have to do the whole solving thing. X equals plus and minus 2i. Okay, now I know that blew a hole in a lot of people's craniums for this early in the coming back from break, but basically, I hope you get this. X squared minus 4 would be x plus 2 and x minus 2. Remember that kind? Okay, so what's different? Well, if this is a plus, then you can't make this thing end up equaling 0 because you'll have a negative 4 as soon as you move that 4 to the other side, and therefore you have imaginaries. So all you got to do to change it, throw in an I here and here. Why? Because when you do first outside, inside, last, now the first will give you x squared. Your outside and your inside will cancel just like they're supposed to, and the last is where all the magic happens, and that's negative 4, but then I times I makes I squared, and do you remember that I squared is equal to what? Negative 1. So the negative 4 times the negative 1 makes it back to positive 4, and that's what we wanted. Whew, heavy-duty stuff for a Monday after break. All right, so if you'd like to, you can do it the way I just showed you right there. But I want everybody to have that tool in their tool bag. So I'm going to say, if it had been x squared minus 16, it'd been super easy. Okay, but I'm going to change it to x squared plus 16. Factor that quick. If you get that factored, you'll be able to get the answers so much faster. You're also much less likely on the test to forget that they're imaginaries. See, that's what happens is people have this part of their, factored problem, and then they think, oh yeah, the answer is 4 or negative 4. No, it's not. That doesn't work. Would you tell me what that puppy factors to? You've got it. Good. 1 down. 2 people have it. 3 people have it. 4 people have it. Don't even give me the answer. Just factor it. 5 people have it. 6. I think you have 2 pluses. 1 needs to be a minus. 7 people have it. 8 people have it. 9, 10, 11 people have it. 12 people have it. 13 people have it. 14 people have it. 15, 16, 17, 18, 19, 20, 21, getting close, 22, 23, 24, forgot one of those has to be minus. Is it minus? Oh, it's a minus. It's just I couldn't read it. Okay, good. Good, I think that's pretty much everybody. Awesome. This was x plus 4i and x minus 4i. Why does it need the I? Because you cannot make this thing equal 0 if you really is the big picture. You can't. In the real world, you can't. Because you can put in any numbers you want, and you're never going to make this become a negative. So it's always going to be bigger than 0. So we have to fake it, and we have to use imaginary numbers. So here's my i's making this thing work out. Okay, so then the answers are x equals 4i and negative 4i, so plus and minus 4i. And if you do it this way, you will avoid having to show me all of this work. Watch what I'd have to do if I don't factor it that way. I have to go x squared plus 16 equals 0. X squared equals negative 16. Square root, square root. Then all these things that kids forget come into play. They forget this is absolute value. You won't have to forget that because you won't have to do that. You'll have factored it already. And then you'll have the square root of negative 16, which is 4i. And then you'll have to remember to slap on the plus and the minus for I. I'm actually fine with you doing it that way. I'm just trying to show you another way that I think makes kids have less mistakes on the test. Because I think you'll know where to put that in the answer blank. Because it's got an I on it, you'll know it's imaginary. That's the other thing kids do all the time, is they take the answers and then they make the answer negative, or sorry, they'll think that a negative answer means that it's imaginary, and it's not. It's only if there was a negative underneath the square root. All right, so there's going to be a spot for imaginary answers, and there's going to be a spot for real answers. The only thing that should ever go on an imaginary answer is if the answer has an I in it. A lot of kids think that if there's square roots sometimes, they think that they're imaginary. Nope, square roots are real. It's square roots of negatives, they're imaginary. So here's a typical mistake answer. I go, okay, my real answer is 4, or plus and minus 4, and they think that plus and minus, no, they think plus and minus the square root of 2 should be there for imaginaries. Because they think, oh, square root of 2 is kind of weird, or they think that it must have to be an imaginary. Does there have to always be imaginary answers? No. It's only if you have negatives underneath the square roots. So what if you left it this way? Then you lose the point because you didn't have what letter in your answer? An I. So what should this answer have been? If that's really what, if the kid was on the right track, then the right answer really should have been plus and minus I root 2. You can never leave negative square roots in your answers. Okay? Now this test isn't until Wednesday of next week. I just am trying to tell you, kind of give you a feeling for where the most common mistakes are. And it's all about imaginary and real answers. That's where all the mistakes are made. Most of you guys will figure out how to do the factoring. But getting those imaginaries and real straight right from the beginning here is a good idea. And I hope it's going to work and you're going to nail the test when the day comes. All right, everybody get to this one. Factor, then find all solutions. All right, so the factoring part, you just have, if it's got 3 parts like this, you just make 2 sets of parentheses and figure it out. You can do it. Pause for a second while you do that. This is not easy, I know, but it's doable. All right, so let me show you in case you're really stumped here. Let me get you started. This 2x to the 4th is obviously different than the one before this. So hopefully you knew to make this 2x squared and x squared. How many of you started right on that? Okay, is there any even smarter way to start? 4 or 5 people have a smarter way to start. Because there is. What do you think? Take out the 2 from everything. Do you see how there's a 2 in everything? There's a 2 here, here, and here. Anytime you can do that, it makes your life so much better because all the numbers are smaller from now on. See, the 2 comes out, and then I have x to the 4th minus 7x squared minus half of 36 is 18. Now it's going to factor so much easier. I don't have to deal with that clunky 2x squared on the front. I can have just an x squared and an x squared, making x to the 4th. Now it's just like the one before. Okay. And the 18 is probably a 9 and a 2 because that also makes a 7. I hope you can do that kind of stuff in your head by now. So the 9 and the 2, 9 and the 2, and then which one needs to be negative? Probably the bigger one so that the big middle term can be negative. Let's see if I've got it right now. First, outside, inside, last. First is that, and that makes x to the 4th. Outside makes negative 9, and positive 2 makes negative 7x squared. Yay. And the last make negative 18. I'm good, except I'm not. I didn't factor it all the way. Sadly, kid loses point right here because the kid didn't factor it all the way. Do you know what I'm talking about? Does anybody know what I'm talking about? Yes, sir.
You're talking about factoring out the x squared plus 2 to be, that would be imaginary. Right?
Yes, you could factor that part out, but that would be a trickier one because this would have a square root in it, so it's the other part.
Yeah.
So the other part, tell me about the other part, this part.
Okay, so it's going to be x minus 3 x.
You got it. See, it isn't factored all the way until you've done that. Now I'm bringing these parts down. Now it's factored all the way. This was factored, but not factored all the way. It's sort of like being reduced, but not reduced all the way. Until it's, you know, if you leave your answer as well, if it starts out at 16 over 32, yeah, it's good if you bring that down to, 4 over 8, but that's not reduced all the way. You're supposed to reduce it all the way to 1/2. Well, this is factored, but it's not factored all the way. That's factored all the way. And now, what are my answers? Well, if this is equal to 0, then this part needs to equal 0, x equals -3. This part needs to equal 0, x equals +3. This part needs to equal 0, ooh, tricky part, x squared plus 2 equals 0. X squared equals -2. That's impossible. Ooh, square root of a negative. I know we need that I thing. Absolute value of x, I root 2. I'm really close, but I haven't finished. X equals plus and minus I root 2. And here's another good way to make sure you don't forget that. See, this is the part. Everybody forgets that plus minus. So what I want you to do when you're done with the problem is ask yourself if you have enough answers. This is supposed to have 4 solutions because it's to the 4th. Did you know that? That's something called the fundamental theorem of algebra. If it's to the 4th, there's going to be 4 answers. If it was squared, there's going to be 2 answers. If it's to the 3rd, there's going to be 3 answers. So you look through your answers, see if you have enough. You see how if I forget this, I forget the plus minus, I'm going to see 1 answer, 2 answers, 3 answers. Wait a minute, there's supposed to be 4 answers. And the most common thing you forget is, oh, that's right, in here, because of this absolute value, I need 2 answers there. 1 positive of it and 1 negative of it. Now it's got 4 answers, and it's supposed to have 4 answers because of that. Yes, sir?
Can you condense down the x equals 3 and -3 to x equals positive -3?
I am okay with you writing this answer as plus and minus 3. Yep. So that's good for those two. Yes. So there's 2 answers. Here's 2 answers. Total of 4 answers. Yay. Which ones are imaginary, by the way? This one's the ones that have the I. Does every problem have an imaginary? Does having a square root in it make it imaginary? No, it's only square roots of negatives. Yes, sir.
For the next one,
Next problem. All right, let's jump to that one, everybody.
how does that have 3 solutions?
Good question. It does. You'll see in a second. So first, you can't factor a 2 out of everything, but what can you factor out of everything? An x can come out of everything. And then it'll be x squared plus 6x plus 9, and then it'll factor again. Go ahead, finish factoring this puppy. Now, do you see the other answer?
Well, yes, but then two of them are still the same.
Okay, let's keep going.
It'll be x.
Put this right here. Thank you very much. So would you agree it's x plus 3 and x plus 3? Okay. So what you're saying is, wait a minute, Mr. Server, how can this have 3 answers if this one is x equals 0? First of all, I'm glad you knew that one. A lot of people don't know that that's an answer. But you're saying since this is the same exact thing, x equals -3 is the answer to this and to this, it seems like it only has 2 answers, -3 and 0. But this one is a double root, so it counts for 2, okay? So like, for example, if I had this graph, do you remember how a triple counts for 3? It only touches once, but it counts as 3 roots because there's actually 3 of the same thing, okay? So this one is got a bounce at -3, bouncing right there, and it's going through 0 right there. And so, and this one is a lead coefficient is positive, and so it must be going up on the right and bouncing there, and so it generally looks like that. You remember how that works now? And it's got 3 roots because it's a double, for 2 for that, 1 for that. Oh, so much to remember. All right, but right now, all we really, I'm not going to make, graphing is not on this next test, don't worry. I'd like you to remember it, but what we needed you to know was, what are the solutions? The solutions were 0, very easy to forget that one. That can equal 0 by putting in a 0. So 0 and -3, and would you have to list -3 twice? No. You could say 0 and -3 are the solutions. But you got to be careful then to not go, okay, wait a minute, it seems like I only have 2 solutions, and I'm supposed to have 3. Well, it's actually because this is a double solution, a double root. Yes, sir? Okay, yes, you are right. It's supposed to be bouncing at the -3, and actually, yeah, I drew that wrong. I'm sorry. Okay, hold on. So if I'm going to say my two roots are 0 and x equals -3, let me make sure I've got this straight now. Yep, -3. Okay, so the thing I did wrong is going up on the right. That was true. And it's got to be, it's odd, so it's down on the left. All that's true. Now, what did you want me to do different? Tell me again. Make it bounce on the -3. You're right. And cut through there. Still having one bounce and one cut through. And yes, I think I had done that. I had bounced that in the wrong spot before. Okay, but either way, the point what I was trying to make was that it has a bounce, and therefore it's worth 2, and therefore, yeah, even though it seems like there's only 2 answers, this one is a double root, and therefore counts as 2. All right, complicated stuff. And I think we've done enough of practice of this kind. You would just factor an x out of everything, and it would become easy. Do you see that? All right, let's do another, on to this next screen. This one actually is really easy. Also, it's just got a negative thrown in. Okay, so start, please, by factoring out a -2x out of everything. Okay, and then see if you can factor it from there. Because the negative on the front is a bad thing. That's why we're factoring it out. Take a -2x out of that, and that, and that. Technically, what you're doing is dividing everything by -2x. So if you ever have trouble with these, just divide everything by -2x and see what you get. X to the 4th. Here, the -2 and the -2 cancel, and then that's x squared plus x squared. And then here, we have 2x. No, wait, just 2. Sorry. Is it -2? I think it's -2. Now, to be sure if I'm right, I would go back and go that times that. See and make sure it's that. Really, seriously. Remember, your tests usually don't have that many problems on them. And it's worth taking a minute to make sure you actually did your factoring right. This times this makes that. Let me see, -2x to the 5th. Yes, this times this would make -2x to the 3rd. Yep, and then I try that last one there. -2 times that makes +4x. Good, I did it right. Okay, so now what do? I want to factor it the rest of the way. X squared. A 2 and a 1 can make a 1x squared. Yep, that's going to work. So a 2 and a 1. And then one of them's got to be positive, one's got to be negative. I'm going to make the bigger one positive so that I can get the end result to come out positive. So that's plus and that's minus. Phew. You can go that far and still get it wrong. What did I do wrong? Only one person sees it? Seriously? 2 people see it? Mac, what do you think? Okay, it's fine. Come on, look, close. There's something that's not factored. Fine. Yes, that's top 5 mistakes on the test for sure. Guys, forget that that 1 can be factored. That's like x plus 1 and x minus 1. Then this part just needs to come down. And this part's still -2x. It's a 0, not a 6. I should probably clean that up a little bit. Okay. Phew. Hardcore. Anything things you see that are not factored all the way or anything? All right. I want you to be a little paranoid about that. I want you to be like, is there a chance that I didn't factor this all the way? It's happened twice now out of like 5 hard problems I've done. Happens a lot. Kids forget to do that last step of factoring. So always look through it and go, can I factor that? No. Can I factor that? Well, kind of, but it would take imaginaries. You don't have to do that kind of factoring. All right, it's not a bad idea, but you don't have to. If this had been a 4, I would definitely have suggested you factor it with imaginaries. You don't have to, but I would have suggested it, and I would have broken this part right here then into x plus 2i and x minus 2i. Again, optional, but recommended. That way, when you look for your answers at the end, you'd say, oh, this answer is 1, this answer is -1, this answer is 2, or negative 2i, this answer is positive 2i, and this answer is 0. Okay, but again, I changed the problem just to make that point. That's really a 2 there. So, what are my answers, my solutions? Okay, x equals 1, x equals -1. There's 2 of my answers. How many answers am I looking for? 5. See? This one, right here, if I set -2x equal to 0, that's what's really happening. Divide by -2, x equals 0. That's one answer. Now I'm up to 1, 2, 3 answers. This better have 2 answers. Oh yeah, it's got the imaginary kind. And you can do these in your head if you want to. And go, okay, it's got to be x equals, it's going to be the square root of 2, but it's got the negative underneath it, so I got to remember to make it negative, and therefore I root 2. And then I've still made a little mistake. What did I forget? Plus and minus. Okay. Now, believe it or not, we're still not done. There's something that you haven't learned yet, and that's the 4-part factoring that I reminded you or showed you once before break, and I know it might have stuck in a few of your heads, but this is that 4-part factoring that if it's got 4 things, that's what makes it different than all the other factorings we've done. You can't just jump to 2 sets of parentheses. Well, you actually can if you're really, really good at this, but you're not going to be able to do that part. What you should do is divide and conquer. Abraham Lincoln, a house divided against itself cannot stand. United States. If we got divided in half, we would be much weaker. So he decided it was not worth letting the United States split into 2 parts. We were going to fight for it, and we were going to have the, as they would say in the South, the war of northern aggression. Anyway, nowadays, most of us think of that war as about slavery, and because that was obviously a big part of it. So anyway, we didn't want to divide up the United States in 2 parts, because if you divide it, it's weaker. Same idea on this. If you can divide it and do it in 2 separate parts, it's so much easier to beat it, so to speak. So you just have to factor this part, which a child of age 9 could factor that. 2 comes out, and you got x plus 3. Huh, that was easy. And I factor this part. That's a little harder, not impossible. What comes out of both of them? Comes out of this and that. X squared, and what do I have left? X plus 3, and you'll notice that, by the way, that's a positive 2 there, so if I put a plus there, it helps the problem flow better. That this and this are almost always, there's always going to be something in parentheses that matches. Otherwise, it didn't work. We're usually going to make these so that they will factor. We're not going to give you a big nasty thing and then say factor it and then have it not factor. That'd be kind of evil. Okay, so you're going to find that if something factored over here, it's probably going to show up again over there. And now the final step in factoring this then is to really understand what factoring really is. Go back to this problem right here, the simplest of them all. Do you get that each part had a 2 in it? And so if each part had a 2 in it, I pulled it out to the front, see? I pulled it out to the front, and then I put whatever was left over here. That's basically what factoring really is. Do you get in the big picture now of this problem that both of them have an x plus 3 in them? And so I can pull that out to the front. And after they get pulled out to the front, what is left goes here. And what's left? That and that. X squared plus 2. There we go. Factored all the way. You might want to double check and say, can I factor this any further? Oh, no, that's really clear. Can I factor that any further? Not unless I use square roots, and you don't have to do that kind of factoring. So I'll leave it. There we go. Factored all the way. And then what are the solutions? Just do it like normal. This one has an answer of x equals -3. This one has 2 answers. I personally am going to try it this way this time. I'm going to set it equals 0 and then say x squared equals -2. And then I'm going to go absolute or square root, and then I get absolute value of x equals square root of -2, which is now 2 parts. Break it into 2 parts. X equals negative square root of -2, and x equals positive. Actually, I usually do the positive one here. So negative square root of -2. And that is the most common, one of the most common mistakes. I just screwed it up. What did I do wrong? What? You can't have answers that have negatives under the square root. You're supposed to have a what then? An I. Okay? So then I'm supposed to have an I here. And then the square root of -2 becomes just 2. And this square root of -2 becomes square root of just plain old 2. And then I put an I here. Now, have I got the right number of roots? Back to the original problem. Had x to the third in it. 3 roots needed. I got 1. I got 2. I've got 3. Yes. I got 3 roots. I hope you know the ones that have i's in them would be imaginary. And this one is real. All right, this one. I'm going to give you a second. I want you to try part G here. All by yourself. Act like it's a test question. And seriously, the test doesn't get too much harder than this. You already have got it over half the test. If you understand what we've done today, over half the tests you've already mastered. That's next Wednesday's test. There's just basically one major concept that we have to teach you to get the harder kind of problems right. Now pause for a second. Let me try this one. Okay. I had people check with their partners, and generally it seems like people were okay. I know there was I got to guess about a third of the kids that weren't sure how to do this. These two both have an x squared in them, so that came out to the front. How many of you recognize that? You knew that you had to get an x squared out. Okay, good. And then what was left was x plus 3. And then over here, I already have a clue. I bet you anything that the thing that's going to factor, there's going to be an x plus 3 in it. Okay? So then I go over to this other part and say, well, something factors out to the front. Well, what goes into both of these? Not just 8. -8. -8. And then what do I have left? X plus 3. Otherwise, see, this would be an x plus 3 and that would be an x minus 3, and they wouldn't match up. So I needed to factor out a negative. I factored out a -8. Because you never really want to have a negative right there in your problem. Your lead coefficients, you don't want them to be negative. Much better to have that out in front like this so that the stretch factor just has a reflection on it. That negative can be thought of that way. Okay, anyway, once you get it, so this and this are the same, then you know you're onto something, and those two parts come out to the front, x plus 3, and then what's left over after these two are divided off is x squared minus 8. Could you factor this further? Not unless you use square roots, and so I wouldn't expect you to factor that further. If that had been like an 81, then I would have needed you to factor it further, or it would have been wrong. Okay, but since it's not a nice square root, it's going to be fine to leave it that way. Okay, that's factored. But what's the answer? Find all solutions. So then this is x equals -3. I got one solution. And over here, I said x squared minus 8 equals 0. X squared equals 8. Keep going. X, or square root. Absolute value of x, don't forget that absolute value, equals square root of 8, which reduces to root 4 and root 2. And then that's really 2 root 2. And then I split it in 2 parts. X equals positive 2 root 2, and x equals negative 2 root 2. Man, this involves a lot of math. 3 answers. All right, remember, you don't have to be awesome at this till Wednesday of next week. How many of you nailed this one? How many of you got this all right? I was figuring it'd probably be about half. All right, good. You know what? I think that's enough practice problems off of this sheet because I want to get you some time to work on your homework. So it's not going to be much, but everybody get to your homework, which I have already downloaded. I'm sure you know where to look to find it. It's right here. Unit 8, Lesson 1, Factoring and Factor by Grouping is what we called it. Now, this is a little bit obscene number of problems for a first day back, so I'm going to cut this down for you. I know some people always start the problem, so I'm not going to have you skip number 1, but you may skip number 2, and you may skip number 3, and you may skip number 5, and I need you to do that one. 2, 3, and 5 ought to be enough to skip to make this. Oh, then there's a lot of big, nasty ones at the end. Let's have you skip the very last one, too. 2, 3, 5, and 12 are all skips. Okay? Questions? Yes?
There doesn't appear to be any
You didn't open for you.
There's no file there.
Okay. The file was there earlier today. It has been deleted somehow. I apologize for that. But that does not mean there's no homework. I commit to you that you have to leave here in like a minute anyways, that it's going to be there. And you're going to remember, write down somewhere, skip 2, 3, 5, and 12. Remember to check the answers. They're there too. Now, I also, just to give you incentive to do this thing, I will tell you we are grading this tomorrow and putting it in the grade book. Okay? You don't want a 0 in the grade book. You need to practice. Do your homework. I will start working right now on making sure we get that in the that the worksheet's uploaded again. Okay? So it's Unit 8, Lesson 1, skip 2, 3, 5, and 12. By the way, when it says at the bottom, number of times it crosses the x-axis, really it should say touches the x-axis, because a lot of times it bounces, and so I don't want the kids who are really smart to get this wrong because they overthink it. So touching and crossing mean the same thing, but in your head what you should do is change that crosses the x-axis to touches the x-axis. And remember, only the real ones touch the x-axis. The imaginary ones don't touch the x-axis. You can't see where they are. The real ones are the ones that touch. Okay, so change the word crosses to touches, and I'll make sure that worksheet's there. Okay, that's all I got for the video for today.